Okay, sorry guys that it took some time. We have some really cool PowerPoint animations, so we couldn't skip it off. That's why it took some time. But thank you guys for coming. My name is Jonathan. I'm here with Martin, and we will talk about native OpenVMS in the cloud today, and hopefully are as excited as we are about this. So the agenda for today is first we will introduce a little bit what are we actually talking about when we are talking about OpenVMS cloud, followed by some system topology on how it actually looks like in terms of devices are and bases are connected, all of that stuff. We will follow it up with why we think this is a very good thing. Agree with us. And then Martin will talk some about the 4 ways we have been able to achieve native cloud, some issues and what we had with using multiple disks and how to image backups while not making just instance, and some challenges solving our findings. So what are we actually talking about when talking about native? Well, native in this matter means that it is a non-nested instance. We are skipping the middleman, so there is no or Linux host that you need to maintain. It is just straight up from EMS in the cloud. And previously, when we have been talking about using the nested cloud, it has been the nested version, which is the one on the far left here. So there we have a physical server, we have the L0, which we actually don't have any knowledge about on there. And then we have the Linux host, which we have to maintain. And then inside of there, we have KVM. But the native one is the one we have in the middle, where we only have the cloud server and the L0. But to be clear, this is not a direct bare metal deployment, because there is still a KVM or side of it. The question is just about how many hypervisors we have and where they actually reside. So it's not direct bare metal, but it is native in the sense that it is a non-nested instance. Once again, this is the previous topology we have been talking about when we invested in the cloud. So the nested one, where we first of all, we need to have 2 different VCNs to network, where one is used to SSH into the Oracle Linux host, and we then can get into the investment itself through the second interface where we do a mapping. But then we move to the new topology. See, cool animations like that.
It was that simple.
Yes. We only need to have one network interface where we can SSH straight into VMS, and we are also able to have DHCP on the network interface that is inside VMS, which we are not able to do when we're doing VMS. So it's generally a lot less things that we need to think about. And why do we think this is worth it? You do not need any Linux. You can spend all your precious time on the computer, which is what we all do. And you don't have to mess around with the hypervisors and you fix the settings yourself. You do not need to maintain both a host and a guest system. It's only guest to S. But you still have full console access. So you have access to the manager, into the PowerShell, and basically do it. If this is not for you, however, you do like to fine-tune every time you ask the machine. There are no direct KVM settings for you to actually customize. It's only the options you have on your web interface. You can change some things, but you can't really fine-tune it the same way you can front-end things. If you need a host level VPN, you can also configure it because there is no host in that sense. IPsec, however, on OCI is available directly on the interface level, so you can just plug and play and still use that. And of course, if you prefer wasting your time with maintaining two operating systems instead of one, it's not you. We don't judge you.
May I jump in?
Yeah.
When you say that this is not for you if you want to fine tune every little aspect of your KVM setup, first, what you have to realize is you can fine tune all you want, but you are running on top of another virtualization layer that you cannot fine tune. So the big question is whether that fine tuning actually adds any value.
So here are the four possible ways that we got this working so far. We ran this by the amount of effort it takes to get it set up, which also happens to be the chronological order of how we discovered all of these approaches. But first things first, we of course have to just load the installation ISO and then just boot it and install VMS. You would think that this makes the most sense. I also thought that, but after mounting the ISO and waiting for it to load, I spent 3 days more. It was loading for 3 days straight, and only then I could install it. And then I just had a normal VMS system, but I don't know if it's for the 3 days wait. Because actually we have better options as well. The next approach we took was a transplant. It's basically when we already have a KVM virtual machine, already pre-configured, already VMS installed and configured the way we want it. And then we took the QCAP file, which is our system disk in a virtualized manner. And we uploaded that to Oracle Cloud and put this on that. So that was our already created install that we just plugged right into Oracle Cloud. Then NetBoot, this is my personal favorite. However, it does require 2 different instances because you need another host which serves your VMS install disk. But basically, you're just downloading the installation ISO from another web host, and you're just installing it that way. I'll explain why that is a better idea than just putting in the ISO. And then this might take the most effort. The iPXi is just creating a custom iPXi script which run on boot. And we would also just download the VMS install ISO from some kind of place. So you would still need to have a place where you're serving this ISO from. This has quite good automatability. Is that a word? Maybe.
It is now.
It is now. So yes, you could very heavily script the first steps of the install if you would like. But of course, it takes some scripting to do. Yes, so all approaches are quite similar. These are the steps that you have to do with all. You create a bucket in Oracle Cloud. A bucket is file storage. Basically, you have a folder in there. You upload a file to the bucket. Now, this can be the VMS ISO, which I don't recommend. The iPXi ISO, or a QCAP file, which, as I mentioned, will be your system disk. Then you just create a custom image from it. And a custom image is just kind of like your configuration for your instance. Then you still have to customize some image capabilities, which I'll get into. Don't worry if you don't understand what I'm talking about now. And after you've done that, and everything is customized how VMS expects it, you can create your instance. But this is where the difference is coming. So the first thing, common step is creating a bucket. You just go to storage, buckets, create a bucket, write a very creative bucket name in there, like ISO bucket. You can choose a bunch of different encryption types, whatever you need, but if you leave it default, it's perfect. Then you upload your file to the bucket. In this case, it will just, well, yeah, equal to your bucket and you press upload. Then you just select your file, which will be the VMS ISO in this case, as you can see it. And you will see now you have that ISO in your bucket listed. This is where we have to create a custom image from that ISO file. You have to go to compute, custom images, import an image, don't get scared. On the top, you have to select your ISO file. This is what we have done previous. You don't really need to configure a lot of stuff, but make sure to select QCAM tool. And at the bottom, it really doesn't matter which launch mode you're picking, because none of them fit exactly what VMS needs by default. So we will need to configure these capabilities. So you can see in this is mostly correct, but the firmware is iOS, and VMS will not look like that. We need to set it to VMI. This is where we get into customizing VMS capabilities. Your newly created custom image, navigate there, you edit image capabilities, and hold on. So we mentioned that there are not a lot of there's not a lot of customizability. This is not entirely true. We have a lot of options that we can configure, but you don't need to know all of it. The one major important thing is the firmware. You have to select UEFI. And this is every single thing that you can configure. This will go on for quite a while. And if you want to figure out what is the best possible combination for you, you can probably reach out to us, because we took a long time figuring out what works with what is compatible. So yeah.
And this was the easy one?
Oh, this is all of it.
You have to do this
Okay.
with every different thing.
Wow.
But my point with this one was that you still have the customization options. You don't have to do it. There's only one thing that you need to change, but you are still able to change these options. So after you customize this image, you can create an instance with that big button right there. One thing that was kind of a roadblocker in the first part, we were using this shape called the VM standard E4 flex. That one gave us the i440 FX chipset, and VMS does not like that. We use the Q35 chipset, and since we were using the E4 flex chip, we were not getting that. We have a very simple solution: pick E5 flex, change shape, navigate to E5 flex, and what you can open up this drop-down menu, and you can customize your instance. So this is what your virtual machine will have. You can customize the number of CPUs that you're going to have, the amount of RAM that you're going to have. And one thing to keep in mind, the number of OCPUs directly correlates to how many virtual network interfaces you can have. And another thing, versatility. This is a bit of a tricky thing. Originally, you shouldn't enable versatility. You will not be able to create an instance like that. However, if you have it disabled, create the instance, then edit the instance after it, you can turn versatility like that. Yes, so the first thing, this is moving the ISO. So that will just be Yocto, EMS ISO, and this one. For some reason, it took 3 days. We figured out the reason. When you're creating this default root disk, your system disk, the minimum size you can take for it is 47 gigabytes. And what happens is we end up loading all of the 47 gigabytes into RAM instead of just the 1.4 gigabytes of the ISO. So yeah, it works, but you should be patient with that. This is a better way to transplant. This is where you already create your system on your local machine or on another Linux, like an OCI instance. Reconfigure everything and just plug that QCAP file right into your instance. The only thing you need to pay attention to is that you should really have a similar enough config in that machine as what Oracle expects from you. But OpenVMS is quite forgiving with network parts, disk controllers, but that shape is very important that you have this E5 flex. Also, there's this U-shaped 6 flex. We haven't really tried it, but it should have the same result. I mean, it should work. One thing, originally, we could only mount the system disk as IPv, which gets translated to SATA for some reason. And your first disk will be DK500. Now, normally, this is not an issue. But if you already have an instance installed and your first system disk, I mean, the system disk itself is DK100, then your SSH root will be incorrect. So you won't be able to SSH into that directly. So this is why you should pre-write this before you upload this image. And later on, we managed to get parameterized disks working as well. And that would be DKB1. That's the numbering that it will follow. Why DK500? We have a guess that it's OCI's internal ESXi script doing some stuff, but we have not. This is what's happening. Well, we already have an install of OpenVMS on one of our machines. We upload it to the cloud, and we just right after
Yes, so the next book.
Your note about having to change SSH dollar root, it's not just for that. There are a number of VMS installation kits that put the physical device name in their root variable. I usually end up changing the system.
So essentially, applies to everything.
Samba does the same thing. Python, I think. Anything that's got a root variable.
Yeah, and we should point out that in case you upload and you forgot to change, you can go through the console, so you don't have to rely on it.
Yeah.
So there is always a way.
Yeah.
With the NetP, which is probably best what we found in the marketing transplant, right? And some of you are probably talk Google. Essentially, you root the VMS into file from inside the ISO, and there you also need this which to have another instance or another HTTP server that is providing the ISO. So you connect that HTTP server, which is a copy of the ISO, but the way that you need to ISOs to be able to do this, but it is what it is. And the network procedure basically just downloads it into memory, and then you can solve this from the memory and not the memory doesn't look for 7 gigabytes that it does if you're trying to do the ISO directly. Also, how to do it at the point detail. You enter the environment manager just by typing shell and by shell by selecting it. And in the EMS folder, you see there you do the directory structure. You have process 0, EFI, EMS, you load VMS, and on your HTTP server, you need to have the following directory structure as well. You folder called netroot that is the ISO, maybe netroot /root that contains file. But when after you enter the IP of your HTTP server, you just enter the name which has really exits the cell manager. And there you should just for your installation. And IPX is very similar to Netroot since Netroot has IPX to it as well. But OCI has its default IPX, and you can edit or override it, but we have not yet managed to do this. So instead, what you can do is that you move from a generic IPX after OCI's script is finished. And this also, just as the Netroot approach, it requires HTTP or FTP location to serve the ISO phone, and then it downloads it into RAM, which is the same. And this is a bit complex, but it's a powerful approach because just as Martin mentioned earlier, you can heavily automate it, you can script it, and yeah, basically customize it a bit more than you can with the other approaches. But if you are in doubt, you should stick with the break. That's it's much safer. And yeah, what Russell just mentioned, if you're having issues with SSH or anything, you can always access this native VMS installed on the cloud through the cloud shell function. So this is the basic instance page, and there you have a tab called OS management. And from there to launch a console function, which gives you access straight into the system. Some other topics and some challenges and other things we encountered. Adding more disks than the initial systems was huge problem to begin with, as it wasn't really possible. So with VMS 93 up to 2, we were initially limited to only use one disk, which was 2 disks, and we had to specify that to be IDE on the OCX part of things. IDE did show up as a SATA disk, which is why we use it. But if you mount anything else like paravirtualized SCSI, it did not show up at all. It wasn't. But it requires a patch, and it was a driver issue, DK driver. Because to mount a block volume, we either had to mount it paravirtualized, which shows up as Bergdahl SCSI in this system, or iSCSI, which is not being supported. With the paravirtualized one, we had to attach to the DK driver, and it will be available in Pocket.
But even if you have the old version of VMS, which I'm assuming you do because the update is not out, we still managed to do an entire image backup with only one disk available. We used background, so we created this from RAM, which is quite easy to do on OCI because you can just drag the slider up and then suddenly you have 2 terabytes of RAM. But to do it the safe way, we just use this light BPD approach. So basically netboot, which we already mentioned. So you will understand why we really have to get the animations. If you want to create an image backup, you would boot the live DVD, so you want that. You would create a RAM disk, initialize it, mount it. It's because this way we can do a standalone backup. So, you're not getting any kind of issues because your system is still running and still doing something, and then you're messing up your entire backup. Then you mount your system disk. You back up your system disk or RAM disk, and then it's fast. Like you could theoretically back up your system disk straight to your system disk as a safe set, but we found that this way is faster and it is still safer to back it up to a different disk than the disk you're backing up. So after you created the safe set in your RAM, you copy that safe set back to your system disk. And this sounds quite stupid, but in the install disk, we don't have network connection, and we would want to get this safe set out of our system somewhere. And as soon as we reboot, we would lose this safe set from RAM. Oh yeah, and now we reboot to our system disk where we already have the safe set. Transfer the safe set to another machine. Backup created. How do we do the restore? Do the same thing, do a netboot for the same reason. Then we mount the system disk where? Oh, no, sorry. We again create RAM disk. We need to have that because we need to copy back the safe set from our system disk. And of course, we can access that safe set if our system disk is not supported. remount the system disk. We copy the same step over to the RAM disk. Then we dismount our system disk, remount the disk for it, and then we restore the backup. I don't think that's an point. You reboot your system disk, and that's it. You successfully recovered the backup. Here are some challenges that we ran into while trying to figure all of this out. First of all was the aforementioned chipset, but easy fix. You just have to select the correct shape, and I will be able to pull this off. We also had to do a little bit of trial and error with the different configuration options, the custom image stuff, because in Oracle Cloud, they sometimes use different terms than the generic KVM terms. So we kind of had to mix and match and figure out what was what in Oracle's version of KVM. Burstability, as I mentioned, that's simple. We just need to enable burstability until we've already created the instance without burstability. And we're having multiple disks. You just have to apply the patch that we already have. There are still some things which we're working on. One of the things is on the top, you can see the instances are responsive. That one you will constantly see because VMS is not really reporting back its status and its running status as Oracle expected. And then this is another thing. If you want to reboot or shut down the system, you probably have to force it because the BSI dump terminal was taken out a long time. But what would you say it was like 20 minutes, 30 minutes? Something around that. So that's also not the best. And yeah, one thing to keep in mind that this is leading edge. So we're still figuring out stuff. We're still fixing some bugs, figuring out what's causing incompatibilities. So if you're interested, reach out to us so we can cover more ground. So to conclude all of this, why is this a cool thing? You don't need to have any kind of Linux knowledge. You can just do your regular OpenVMS stuff and you have it served as an instance somewhere in the cloud. No RT issues, no need to plug in videos. You also need the ESXi license cost because it's AVM. You don't need to maintain, patch, and monitor another host machine like we did previously with the nested approach. And of course, this is more efficient as well because you don't have an additional host layer in between. So you get one more CPU port, one more extra public IP address, and basically the KVM host overhead is on Oracle's scope, not yours.
Blair.
Yeah, this is the professional service team. We do a lot of stuff. So if you are interested in this, please get in touch with us. And also here are some QR codes. If you are interested in the cloud, you can click the top one, and on the bottom one, you can read all of our so, yeah.
And most people in that slide are here in the group.
Yes, so just look for any of those people there and ask us whatever you want to talk about. Any questions?
Where do you get your IP address?
I mean, the public or the private?
Public.
So public, there are two methods. You can sort of rent no, actually three methods. You can bring your own. So OCI accepts bring your own IP. OCI accepts.
Yes.
OCI accepts bringing your own IP, in which case you have to send them the details, etc., and then you just do your own IP, you're just using that. And you have a second method, which is you rent one of OCI's IP, but it is yours as long as you rent. So it's what they call the IP reallocation. So, something like, so basically the idea is that you get an IP, you like the number, it's a beautiful number, it's like IP4 and you're happy with it. It's the best number. It's not as good as 888888. And you keep that so you can actually reuse that within different machines if you bring down, etc. So there's option 2. And option 3 is you just take any IP, and once your machine dies, the IP goes with it, and then if you create a new machine, you get a different. So all three.
So there's two ways to end up with a permanent IP address.
Correct.
Okay.
Correct. Both external and internal source for that IPv4. Yeah. We have done very little on IPv6. It's mostly IPv6.
That was pretty much what I was trying to figure out. I love how you get the permanent IPs to put in if you're going to put this in something.
Exactly.
Like your DR, whatever.
Yep.
So you can put it in the favorite file with that file.
I guess if you bring your own IP, you need to set up routing on your side so that that IP gets routed to your infrastructure back to your cloud
Yep.
infrastructure.
It's a file.
Yeah, actually.
I've never done both, but I know that Oracle has been going on. And I'm pretty sure that it is quite easy to.
So I heard talking about that this whole method of eliminating OEL KVM or any was you tried it and we're not able to do it from the signal.
So we tried with Azure, and Azure we can only test for the use to have, which is then called OpenVMS. And with AWS, just with AWS, we have been able to run the brightness solution, which is physical server, which we are generally talking about here now. Yeah, bare matter is basically a bare matter with the microphone, and that means a order magnitude of firewalls. Plus the fact that it's a physical server, and then now one thing the guys did not mention is the moment you have a virtualized instance, so either the middle block or the leftmost, you get vMotion for. So you get vMotion for. So the whole idea of Oracle on KVM, even if you have a single node and it's a single instance, it is still protected and closed by Oracle's own KVM. The moment you go to a physical server, then it's up to you to actually have two physical servers. So you're actually then yourself installing it. So it's yet another advantage of going to either the mid-block or the. So even a very simple 4-core CPU, 4 gigabyte RAM, 50 gigabyte hard disk, that doesn't cost much. You get vMotion by being on the other side.
And the big difference between Oracle OCI and other cloud providers that makes this possible is that Oracle OCI is and not on SAN or hyper or anything like that.
You created two VMS guests on the same host. Do you even know if you're on the same host?
Yes.
You can create one native instance with DNS, so that would just be like one KVM machine, and that's it. And I don't think we mentioned it, but we also managed to cluster it together
With what?
with IPCI. So that's the thing. We normally have access to the layer 2. So that unfortunately does not work. We have not really found a way to make it happen. Only through IPCI.
We'd already done anyway.
Yes.
The herder, that's a cool project that we were talking about last year on the bootcamp. Almost this year.
No, it was my
Random. So we have this hackathon project where we are automatically spinning up a bunch of different VMs with our own configuration, our own list of products that we want to install in that system. And what were we trying to get?
then we get 64.
Well, yeah, there we can have up to 64 guests flying simultaneously.
You're a customer interested in PCI passive on KVM, I think it's possible to shape. Was that or is that?
No. Cloud and fiber channel, it's not available.
Yeah.
You got the Bergdahl solution.
That bare metal is still sitting in an Oracle data center. It's still the same hardware that we use everywhere else. Oracle is not going to put fiber channel infrastructure into their data center just to accommodate your needs.
This is exactly the discussion that led us down the ESXi road.
Yeah, right. Yeah.
Exactly.
Yeah. Thanks for listening.
Thank